I, Himabindu, along with my friends Apurva, Bhavani, and Rajani, did a project on cloud computing security from single to multi-clouds under the esteemed guidance of Mrs. TMP Madhuri Ma'am. First, let me explain what is cloud computing. Cloud computing is nothing but the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or PC. In other words, all the hardware and softwares can be handled by the users sitting at one place or somewhere inside the network. It is provided to the user as a service by another company and accessed over the internet. The user would be unaware about the location of the hardware or software. It would be just somewhere up in the ubiquitous cloud that is represented by the internet. On-demand computing. It is a kind of internet-based computing popularly known as on-demand computing. On-demand is often referred as pay-as-you-go or subscription basis. So we typically buy the services provided by the cloud the same way we do it for telephone services, electricity, etc. We can avail the services according to our need. We don't need to buy or set up the giant computer system. By this it is clear that by opting cloud as a service, we can reduce the infrastructure and cost. Here comes a question, what makes cloud computing different? There are three features which makes it unique. It can be easily managed, it is on demand as said earlier, it is both public and private. Let me explain them in detail. The service we use is provided by someone else and managed on our behalf. For example, if we use Google Documents, we don't need to worry about the licenses for word processing software. Google does everything for us. We just have to concentrate on whatever the job is. Cloud computing comes in two flavors, public and private. Google provides public clouds. Private cloud computing works in much the same way, but we access it through secure connections. Types of cloud computing. They are of three types. Infrastructure as a service where we access raw hardware, software as a service where we use web-based software, and platform as a service where software and hardware are provided by another company. Cloud computing security. It is referred to a broad set of policies, applications, and associated infrastructure of cloud computing. Security is the most prioritized aspect of any form of computing. As the cloud computing approach could be associated with having user-sensitive data stored both at client side as well as in cloud servers, identity management, data storage, and authentication are very crucial. Here comes our problem definition. The use of cloud computing has been increasing rapidly in many organizations. Small and medium companies use cloud computing services for various reasons because these services provide fast access to their applications and reduce their infrastructure costs. Cloud providers should address privacy and security issues as a matter of high and urgent priority. Dealing with single cloud providers is becoming less popular with customers due to potential problems such as service availability failure and the possibility that there are malicious insiders in the single cloud. Hence, dealing with single cloud is malicious. A movement towards multi-clouds, inter-clouds, or cloud of clouds has been done. This project focuses on the issues related to the data security aspect of cloud computing. As data and information will be shared with a third party, cloud computing users want to avoid an untrusted cloud provider. Protecting private and important information such as credit card details or a patient's medical records from attackers or malicious insiders is of critical importance. In addition, the potential for migration from a single cloud to a multi-cloud environment is examined and research related to security issues in single and multi-clouds and cloud computing are surveyed. Hence, this paper serves as a recent research related to single and multi-cloud security and addresses the possible solutions. Use of multi-cloud providers has received less attention from the research community. This work aims to promote the use of multi-clouds that have the ability to reduce the security risks. Now, let us examine the existing system and the proposed system. Cloud providers should address privacy and security issues as a matter of high and urgent priority. Single cloud doesn't address security issue. Therefore, dealing with single cloud providers is decreased. It is decreased because of the potential problems such as service availability failure and the possibility that there are malicious insiders in the single cloud. Hence, a movement towards multi-cloud has been initiated. The advantages of the proposed system are data integrity, service availability, and the user runs custom applications using the service provider's resources. Cloud service providers should ensure the security of their customers' data and should be responsible if any type of security risk affects their customers' service infrastructure. Now let us get into the modules of the project. The modules involved are data integrity, data inclusion, service availability, and web-sky system model. Data integrity. One of the most important issues related to cloud security risks is data integrity. The data stored in the cloud may suffer from damage during transition operations from or to the cloud storage provider. CashNet gives examples of the risks of attacks from both inside and outside the cloud provider, such as the recently attacked Red Hat Linux distribution service. One of the solutions that they propose is to use a Byzantine fault-tolerant replication protocol within a cloud. Hendricks states that this solution can avoid data corruption caused by some components in the cloud. However, CashNet claims that using the Byzantine fault-tolerant replication protocol within the cloud is unsuitable due to the fact that the servers belonging to the cloud providers use the same system installations and are physically located in the same place. Data intrusion. According to Garfinkel, another security risk that may occur with a cloud provider such as the Amazon Cloud Service is a hacked password or data intrusion. If someone gains access to an Amazon account password, they will be able to access all of the account's instances and resources. Thus, the stolen password allows the hacker to erase all the information inside any virtual machine instance for the stolen user upon modify it or disable its services. Furthermore, there is a possibility for the user's email to be hacked, and since Amazon allows a lost password to be reset by email, the hacker may still be able to log in to the account after receiving the new reset password. Service availability. Another major concern in cloud services is service availability. Amazon mentions in its license agreement that it is possible that the service might be unavailable from time to time. The user's web service may terminate for any reason at any time if any user's files break the cloud storage policy. In addition, if any damage occurs to any Amazon web service and the service fails, in this case there will be no charge to the Amazon company for this failure. Companies seeking to protect services from such failure need measures such as backups or use of multiple providers. Web-sky system model. The web-sky system model contains three parts: readers, writers, and four cloud storage providers, where readers and writers are the client's tasks. Basini explains the difference between readers and writers for cloud storage. Readers can fail arbitrarily. For example, they can fail by crashing, they can fail from time to time, and then display any behavior, whereas writers only fail by crashing. Now let us look into the requirements. This section summarizes the hardware environment under which the development takes place and also the languages and operating systems that will be used for the development of the project. Hardware requirements. A minimum Intel i3 core processor for optimum performance with speed 1.1 GHz. A minimum of 4 GB RAM for Windows 7. A hard disk of 320 GB. Software requirements. NetBeans IDE 7.4 is used as an IDE for the development. Java programming language JDK 1.5 or 1.6 for coding along with JSP, and the operating system used would be Windows 7 and above. Frontend used is HTML, Java and JSP. Script used is JavaScript. Server-side script is Java server pages, and the database used is MySQL. Now let us go to the execution of the project. Okay, so before getting into the execution, let me give the overview about the tool that we used and also about the algorithm and the logic with which we built the project. The tool that is used to develop this project is NetBeans IDE 7.4, in which we have written some web pages with which the project runs, and the algorithm that we used is secret sharing algorithm. This is introduced by Shamil as a solution to the privacy issue. The algorithm proposed divides data into D pieces in such a way that the knowledge of any K or more of Di pieces makes the value of D unknown. Therefore, a complete knowledge of K-1 pieces reveals no information about D, and K should be less than N to keep the values of shares unconstructible and ensure that the adversary cannot access the key data pieces. Sharma's method theoretically secures information. In addition, by using k, n threshold scheme with n is equal to 2k minus 1, he shows that a strong key management scheme can be achieved. The goal is to take a distributed approach to secure database as a service, the reason being that they want to explore the use of a secret sharing approach and multiple service providers. The advantage of this approach is that it addresses both privacy preserving querying and data security of data. And the protocol that we used is Byzantine fault tolerance replication protocol. This can guarantee the robustness of systems by building a group of one cloud manager connected to 2F plus 1 clouds where up to F replica are faulty at runtime. The contribution of this work is as follows. This work identifies the Byzantine fault tolerance problem in the multi-cloud computing environment and proposes a Byzantine fault tolerance model named BFT-MCDB to ensure the robustness of the multi-cloud environment. The model presented in this paper relies on a novel approach that combines the Byzantine agreement protocols and Sharma's secret sharing algorithm to detect Byzantine failure in the multi-cloud computing environment as well as to ensure the security of stored data within the cloud. BFT-MCDB is based on a state machine approach which has a replication mechanism. Viewing our model in terms of state machines helps in understanding how our model replicates the data in the multi-clouds and centrally controls these clouds by the cloud manager. Okay, now let me start the execution. First open NetBeans IDE 7.4 and then open the project. Go to File, Open Project, click on Cloud Security, that's our project, and say Open Project. The Cloud Security project is open. Now click on Clean and Build. Then again right click on Cloud Security and click on Run. After the project is deployed, a web page opens in the Chrome browser. This page appears in the Chrome browser after the project is deployed in NetBeans. Now click on the Client Login tab and give the login details. After we are successfully logged in, we need to upload the files. So click on the File Upload tab. Now give a file name to the file that which we are going to upload. I am giving it as hello. And the file can be uploaded to any one of the 3 clouds. I am choosing Drive HQ, that which we are going to upload. Open and click on Upload. Now we can see that the file which we uploaded is divided into 3 clouds, indicating that the file is using multi-clouds. Now click on Upload button. Now the file is successfully inserted. Now log out. This page appears in the Chrome browser after the project is deployed in NetBeans. Now click on the Client Login tab and give the login details. After we are successfully logged in, we need to upload the files. So click on the File Upload tab. Now give a file name to the file that which we are going to upload. I am giving it as hello. And the file can be uploaded to any one of the 3 clouds. I am choosing Drive HQ, that which we are going to upload. Open and click on Upload. Now we can see that the file which we uploaded is divided into 3 clouds, indicating that the file is using multi-clouds. Now click on Upload button. Now the file is successfully inserted. Now log out. Now the uploaded file must be verified by the cloud owner and also the service provider. So first click on cloud owner and enter the details. Now we need to verify the files. Click on verify here and the status is changed to yes as the file is verified. Now click on log out. Now click on service provider tab and give the details. Now click on verify file tab to verify the file. Now click on log out. Now if you want to download the file which we uploaded, go on to client login tab and give the details. And click on download file tab. Now as the file is divided among 3 clouds for ensuring the security, we need to verify each file in 3 different clouds. So click on verify. And finally click on view file to download the file. This is the execution of our project. Hence, in conclusion, it is fairly lucid that storing the data over multi-clouds is efficient, and when this data is encrypted using Sharma's secret sharing algorithm, it is guaranteed to be more secure and harder to compromise. Furthermore, data intrusion leads to many problems for the users of cloud computing. The worst-case failing probability of the system is low, and the time complexity of the system is reduced. The purpose of this work is to survey the possibilities of a system that will take the best of both multi-clouds and secret sharing algorithm to address the present security issues and present a possible solution. And also we have found that much research has been done to ensure the security of the single cloud and cloud storage, whereas multi-clouds have received less attention in the area of security. We support the migration to multi-clouds due to its ability to decrease security risks that affect the cloud computing user. The scope of this project is that the combination of multi-clouds and secret sharing algorithm is promising, but as of yet it deals with many uncertainties. The current work ensures implementation of only text and relational database. Inclusion of images and audio handling capability might increase the size and complexity of system. The number of data instances depend on users' affiliation with cloud service. The maximum size of data is again one of the factors that we have to deal with in practical implementation. So for future work, we will try and overcome to all these limitations or find an alternative for the same. Thank you.